This is the last lesson of Unit 2 Polynomials, lesson number 7, and it will cover factoring special products. So what is even a special product? A special product is an expression that doesn't fit into the normal ax squared plus bx plus c. So there can be two special products. There's two cases. There can be difference of squares product or a perfect square trinomial product. Okay, so a difference of squares product is when you have two terms that are perfect squares that are subtracting from each other. So in our last lessons, we haven't learned how to factor two terms yet completely. We've only learned how to decompose or factor simple or complex trinomials. We haven't learned how to actually completely factor two terms, which are perfect squares. So when we have a squared plus b squared, a squared minus b squared, it can be a and b are just numbers, with a has a variable usually, and b can sometimes have a variable. But it can be like 4x squared minus 1. This is a difference of squares because you have a squared. 4x squared is a perfect square, right? Because 4x, the square root of 4x squared is just 2x. And 1 is also a perfect square. So a square root of 1 can be 1. Okay? So that's essentially what the difference of squares looks like. So how do we even factor it? So we factor it by turning this into a plus b times a minus b. A and b are square roots of these. Okay? A squared minus b squared. And then you take the square root and then you just plug it in to the two brackets. A plus b, a minus b. So let's take a look at an example, okay? So sometimes your difference of squares, it would not be a perfect square without factoring. So this is an example, right? 27 and 3. They're not perfect squares, but you can factor out 3 to make them perfect squares. You can factor out 3 to make it 9k squared minus 1, which is a perfect square, which are perfect squares. Which then this bracket is a difference of squares. And then from here, you can just apply the formula. Okay, so a in this case would be 3k, because the square root of 9k squared is 3k, and then b would be 1. Okay, and then you just plug it to the formula, and this is your final answer. Okay, our next sort of case would be perfect square trinomials. So for the difference of squares, it's a must. A difference of squares is the only way you can factor out two terms completely. However, for this perfect square trinomial case, you can do decomposition. You don't have to use this shortcut, but it's ideal because it's much faster. Okay. So we've learned it, but so this comes in 3 terms. Okay, it's still in the form ax squared plus bx plus c, but it's a little bit like changed. So it becomes this: a squared plus 2ac plus c squared. So a squared can be anything. 4x squared, 16y squared, or maybe like 64xy squared. X squared, y squared. Okay, so it's essentially a perfect square coefficient following a perfect square coefficient in front of a perfect square variable. And a perfect square variable, to clarify, a perfect square variable, it could be x to the 4th or like a to 6. As long as the power is an even number, then it's a perfect square, because the square root of, let's say, x to the power 4 is x squared. Okay, so that's just a little like heads up. But yeah, so x to the power 4 or a to the power 6, as long as the power is a even number, then it's a perfect square trinomial. And the coefficient, of course, has to be a perfect square. Okay, so that's the a squared. The bx here turns into 2ac. So AC is just the square root of a and c, and then 2 is just 2 times the square root of a c, like this. Okay, so the middle term is 2 times root of a and root of c, and that becomes the middle term, the b term. Okay, and c squared is the same thing as a squared, where you have sometimes you have a coefficient that's a perfect square, but usually not. So c squared is another perfect square. Okay, so it will turn to this. So it depends on the sign. It could be a squared minus 2ab plus c squared, or a squared plus 2ab plus c squared. So plus and minus. Okay, it could sometimes be plus, sometimes be minus. Okay, so you just essentially just simplify this into a plus b squared, or a minus b squared. It doesn't really matter. Okay, it matters which the sign you'll carry over here. Okay, the sign, but just essentially put a bracket around a and c, the square root of a squared, b and c squared, and you put a whole square around it. Okay, so let's have a look at the examples. Okay, so 9n squared minus 24n plus 16. So we recognize that it's these two are perfect squares, right? Because 9n squared, the square root is 3n, and 16, the square root is 4. So we know that it's a perfect square, but now we have to verify that the middle term is 2ac. Okay, so a is 3 and c is 4. Okay, you kind of you could ignore the variable, but you can just put it as 3n. Okay, so 3n, 2 times 3n times 4, which equals to 24n, right? So 2ab. Okay, you plug in 2ab. Does it equal the middle term? Yes, it does. So yes, it is a perfect square trinomial. It passes the test. Okay, and now we just plug it into the formula. So now it's a negative, right? It's a squared minus 2ab plus c squared. So we just use this one, a minus b all squared. So a is, again, 3n, and b is 4. So a minus b all squared. This is your final answer. Okay, so now let's do some examples. So we look at this trinomial. We see that these two are perfect squares. So let's check if 30 equals 2ab. So 2ab, that equals 30x. So yes, it is a perfect square trinomial. From here, just apply the formula, right? It's a subtraction, so it's 3, so it's a, so 3x minus b, which is 5, all squared. Okay, that's your final answer. It's very fast. Okay, let's move on to this one. So it's not yet in the form of difference of squares, but you do see the two terms being subtracted from each other. That is a hint that it can become a difference of squares. So what can we do here? We can just take out the 2. So 2, we factor out the 2. So 4v squared minus 1. Now this is a difference of squares, okay? Because a squared minus b squared. These two are both perfect squares that are being subtracted by each other, okay? So from here, we just apply the formula, which is a plus b times a minus b, okay? So a is 2v, and then b is 1, and then, yeah, this would be your final answer, okay? Okay, let's do the last question. So we have this. Again, it resembles the difference of squares, but it's not yet in that form. So what can we do to make it a difference of squares? We can factor, okay? So we will factor out 5. So when we factor out 5, we're left with 25x squared minus 16. Okay. So now this is in the perfect square, a difference of squares form, okay? So now we can just apply the formula, a plus b, a minus b. Boom. Okay. That wraps up your Unit 2 polynomials unit. Good luck on the next unit.